Okay, so yesterday we looked at the sine rule, which was the rule that you can use when it's not a right angle triangle. You can technically use it still with a right angle triangle, but when we do have a right angle triangle, we can use SOHCAHTOA. But when we don't, we can use these other rules. So these, we had the sine rule, and then we've got another one called the cosine rule. So it's still going to be how you draw those, the triangle. So we're going to have a triangle that's probably not a right angle. We're going to call the angles A, B, C with a capital letter, yeah? And then what we refer to is the side opposite that capital letter as the little letter side. So that would be little a, this would be little c, and this would be little b. So that's how we label our triangle, and then that's why we do that is because the formulas that we use to find an unknown in our triangle, we'll use those letters and that system. So here, when we've got the cosine rule, we've got these, first of all, we've got these three rules here, and they're used when you're trying to find a side of a triangle. Okay, so you can see that in the formula we have the function cosine, so that's why they're cosine rules, and you can see that they're using the letters of the side lengths of the triangle. Okay, so if you had to find side A, you'd use this first one. If you have to find side B, and so on. So there's the three combinations. Okay, that can be used if you want to find the side length. And then we have these three formulas here where if you're trying to find one of the angles, find an angle. Okay, so you can see once again the formula has cosine in it, and this is when we're trying to find the angle. So if we're trying to find angle A there, that's what we'll use. Okay, so we just can continue using our solve function, and I want you to do that. So, and we'll keep using that. So let's go and do a couple of examples. So here, when we get the first one, it says find side C correct to 2 decimal places. So your first step, like with what we were doing, we should always label up the triangle. So you can see we've labelled that there C is the question, and then I could label the other ones. So this would be side B, and this would be side A. Okay, now because at the moment we're in the cosine chapter, so we're going to be using one of the cosine rules. In a minute, I'll show you how you can pick which one you need to use if they're all jumbled up. All right, so we want to find side C. So I'm going to get the C formula, the side C formula. So I'll go grab it. Okay, so what you would do is you're going to use this formula. So you'd write out that one. So you've always got your reference book in your notes, and you go, all right, this is the one I'm going to use. And then what we would do is we're going to substitute in what we know. So C squared is what we're trying to find. Now, side A is 34. So the formula says to do A squared. So I do 34 squared plus B squared. So B is 27. So I do 27 squared. Then the formula says minus, then it's 2 times A, which was 34, times B, which is 27, times cos, now angle C. Now they told me angle C was 50. So what you do, you've written that out, and now all you have to do is pop in solve in your calculator. So we're only finding a side length, so we'll just have to do solve, and we can do comma C. So take note, the formula says C squared, but you just want to know what just C is. So at the end, we write comma C, but this formula has a C squared at the start. All right, so let's go do that on our... So we've popped that into the calculator, and it has said 2 decimal places, so we got C equals 26.55. At this point, I'm looking for units in case I have to put it. So I mean like centimetres, kilometres, whatever. There's no units in the question, so I'll just leave it like that, yeah? All right, let's start with this one. Now, with this one, it says find the largest angle. So you need to write a little note here about that. So the largest angle is always found opposite the largest side. So the largest angle will be opposite the largest side. Okay, so, and that is also, where do you think the smallest angle is? Opposite the what? Yeah, exactly right. So here when they say find the largest angle, if I have a look, 6 is the largest side, so A is going to be the largest angle. So I'm finding angle A. Okay, that's what they want me to do. Okay, so we need to go and find, we're in the cosine chapter, so we want to use the cosine formula for finding angle A. So I'll go grab that. Okay, so we've got here, I've gone and found the cosine angle A. So we don't want we'll just type x as our unknown. We'll just call it, we might just call it x up here, just so when we type it in our calculator, it's a bit easier. All right, so we should label this triangle up there. So side 6 is little a, side 4 is b, little b, because it's opposite the capital B, and this would be little c, okay? So when I go to substitute in using this formula, I'm going to write cos, now x is the one A is what I want to find out. Now b is 4, but it's squared, so 4 squared plus 5 squared minus 6 squared over 2 times 4 times 5, okay? We're going to copy that and type that into our calculator, except we're going to put solve, and because we're finding an angle, we like to put an n in front of it. So n solve, and I'm going to go comma x. So I'll give you a bit of chance to type that in your calc and see what you get for your answer, remembering they're asking for 1 decimal place. Okay, so we found x to be 82.8, but I should refer back to the question, so I might just say angle A, because that little symbol that I just drew is a symbol for angle, so I might say angle A equals 82.8 degrees. Okay, if you write capital A equals 82.8 degrees, you'll be right. That's okay as well. All right, so this next one. So this one, we're just putting words in it. It's still the same. So a yacht left at point A and sailed 15 kilometres east at point C. So remember what they're doing here. You are starting at this point A. So if you remember back to our compass bearings, here's like the compass, you know, that dotted compass. And then they just said then, they said it left point A and sailed 15 kilometres east to C. So what they did is that direct line, a straight line across there to C, okay? And another yacht also started at point A and sailed 10 kilometres out to point B. So there's what that second yacht do. So this was yacht 2. This is yacht 1 out here. Okay, the distance between the two of them is 12 kilometres, so you can see that there, they've drawn that. Now, what is the angle between their directions as they left point A? So what they want, what the angle between them, they're talking about this, that x, okay? So what you can see, if we go and we're going to do part A, if we just drew up a simple triangle without all the other stuff. So I'm going to call this A, B, C. I know that this is little a and that's 12. I know this is C and 10, and I know this is B and 15. And they want me to find x. So for me, that's angle A. So I'm going to use that angle A formula again. So I'm going to use this one. So what we'll do is we're going to substitute in. So I'm going to say cos x again and equals. Now this time B is 15. So it's 15 squared plus 10 squared minus 12 squared over 2 times 15 times 10. So we should already have this on our calculator from the one before. So just go up and copy it and then edit it and just change it to the numbers that you need. And comma x. Now they're saying to 2 decimal places in the question, so let's find out what that is. So I've found that to be 52.89, so we should probably just answer the question. So that we'll just say angle between 2 points equals 52.89 degrees. Now the next question here is find the bearing of point B from the starting point of A. So remember when they say from the starting point of A, that's where you're starting. So you're starting from A's north and you're going to go until you hit the line that joins A and B. So they want, I'm going to call it Y, we need to know what that bearing is from that north to that line. Now, if we know at the start, they said that was directly east. So what's between north and east? How many degrees? 90. So can we say for part B then, if I say 90 degrees minus the 52 point, because we know this is 52.89, what would that equal? 37.11 degrees. Okay, so the bearing, so let's answer that out. The bearing of B from A is, 0. We'll just do it to the nearest, I did say the nearest degree, so it's near 0.37 degrees. You can put a T if you like, but you won't be penalised if you don't. Alright, so let's have a look. A bushwalker left his camp and walked 10 kilometres in the direction of 70 degrees. Alright, so if we look, so here's their starting camp here, and you can see when they said the 70 degrees, so that's them, and they've walked out here 10 kilometres. His friend also left the base camp and walked in a direction of 120. So here's the friend. So this is the friend walking out for 8 kilometres, and his angle is 120 there. Okay, find the angle between their paths. So what they mean there, if I call that x, that's this angle in between their paths. What is that angle? If all the way to here is 120 and then just to here is 70, what does that make this one in here? 50. Yeah, 120 minus the 70 equals 50 degrees. All right, so we can work that one out. So it says, how far apart are they when they stopped walking? So they've called that, how far apart? They've called that little a, okay? So this is them, he's here, and they want to know how far apart. So all you have to do is probably just simplify that triangle. There's too much info on there, and it confuses us. So we're just going to draw the triangle out, and they've been nice. They called it ABC for us. So little a is what I'm going to find. I know this is 8. I know this is 10, and also know that this is called, this is little b, and this is little c. And we also found out that A was 50 degrees. So we know all that. So we're in the cosine and we need to find side A. So I have to go get that formula. Okay, so we've got the formula. This is the formula we want to use. So I write A squared equals, I'm substituting, B is actually 8 and C is 10. So minus 2 times 8 times 10 times cos A, which I do know is 50. So into your calculators, you can do solve and comma A. If you want to call it X, sometimes it's better, the calculator sometimes doesn't like A, or you've used it or something. So it doesn't matter. If you use X, you can use X, but let's go work that out. Okay, so we found A to be 7.82. So they've actually asked how far apart they are. So maybe we should give it a statement. We'll say they are 7.82 kilometers apart. Okay? So, okay, passengers who are traveling in a car west along a road that runs east-west see a mountain away, 9 kilometers away on a bearing. So what is happening, you've got, if we start with this compass, like I'm just going to draw, this is the start. Okay, so the car is traveling along, they're going west, so they're heading this way on the west-east line, okay? And they said they see a mountain. So here I'm going to say they see a mountain, and it is 290 on a bearing of 290. So what you've got to remember when they say that, remember we'll join up, let's join up them. So this is the car. So I'll just say here is the car, okay, and that's the mountain out here. So if we join them up, we're drawing a line. So they're looking out at that thing, at that mountain. So when they say that they can see it 9 kilometres away, so you know that's 9 kilometres, on a bearing of 290. That bearing of 290 means they went all the way around from the north line to the line that joins them together. So that's 290. So who can tell me, when we go from north around 3/4 of the circle, how many degrees is that? When you go to the west line, 270. So what would the little angle in between be? 20, good. So we're working out that that's 20 degrees in there. And that's what's going to help us, because they said when they have travelled a further 5 kilometres east, so then they get, west, sorry. So then they move here. This is the stop for the car, the second stop. So they've said that's 5 kilometres west. What will the distance to the mountain? So in the end, the question they want is this distance between the car, the second stop of the car, and that. So once we've drawn that diagram out, it is a little confusing, so we don't need to have all that information. We just want to make it basic. So I'm going to draw out the triangle with just all the information. So I've got 9 kilometres. I know this is 5 kilometres, and I knew this was 20 degrees. And this is what they want me to find, x. So I'm just going to label my triangle up like I normally would. So A, B, C. It doesn't matter which one I call A, B, C. If I've done that though, I'm going to call that A, this C, and that little B. So looking at that, which side do I want to find? Do I need to find? Side, little c. Good. Okay, so I found that formula, and let's substitute in. So I'm going to say x squared equals 9 squared plus 5 squared minus 2 times 9 times 5 times cos 20. And then I can pop in solve. And I called it x, so just do comma x at the end. Okay, so we found x to be 4.6. So therefore, 4.6 kilometres apart.